Good morning, everybody. We are coding Caciques. We're going to present Aerobal, the automated wind tunnel solution. My name is Jesus Tucson. I'm joined here by Juan Lebron, Marlon Marquez, and Anthony Llanos, who are rest of the members from my team. So an outline of what we'll be talking about today. We'll first give out a brief introduction of what a wind tunnel is and what it's supposed to do. After that, we'll go to the problem we're trying to solve, which is basically the old wind tunnel in the civil engineering building. Then we'll go out to the solution that we made, which is Aerobal, the system we finished on. Then we'll follow up to a demo, a short demo video so you can see how the system works now. And we'll finish up with a budget, a small budget overview so you can see how much the system costs. So a wind tunnel is a device to measure aerodynamic characteristics of solid objects. So these characteristics can be measured to see how the object interacts with the motion of air. Here we can see a sports car next to a normal car. You can see that the sports car is a tad more aerodynamic by the way the air flows on top of it. It doesn't bunch up as much here with the pressure. So the wind tunnel, what we use it for is to measure forces called drag, lift, and side forces. And it can also measure moment forces called the roll, yaw, and pitch. We only focused on drag, lift, and side forces, which you can see on the small car here. Drag pushes the car back, lift pushes the car up or down, and side forces basically make it veer left and right. So the problem that we were facing was that the tunnel at civil engineering was old and it was limited by things like a mechanical balance. So the mechanical balance actually had to be balanced out with sand and measured out to get a real measurement. We fixed that up, we made it electronic. It also had a mechanical wind control. If you wanted to control the wind speed, you would have to use a small window to control it. And also the readings are not centralized, so you would have to actually make manual measurements by taking out the sand and weighing it out to see how much force it's exerting.
So to talk about our solution, we'll be talking about how we achieve the automation of the control of the wind speed in the tunnel. We'll be also talking about how we achieve electronic force measurement, how we use digital sensors to take all of the reads from the environmental data. We will also show how we implemented the mobile interface, which interacts with the system as a whole, and the web interface and the experiment data repository, which allows us to visualize all of the experiments conducted in the tunnel. To achieve wind speed control, the main component that we use is a variable frequency driver. This component essentially controls the frequency provided to the motor. It allows us to adjust the current and voltage provided to it to achieve this control. It allows us also to achieve a control with a precision of less than 1 mile per hour. Here now with whatever to explain about the digital environment.
As for the digital sensors, we have replaced every old sensor with wider range and more precision ones. Also, we have added a new model which could measure 16 pressure points at the wind tunnel. This is the current sensor of the wind tunnel, where we have the wind vane, anemometer, and humidity sensor at the center above the car of the object that we are measuring, which is placed on the back, which measures the forces and pressure points that we could locate everywhere on the tunnel. This is the new balance, which is basically a modification of the old one, but has low source, which will measure the axis on a new axis here, which is the zero axis, and have a precision on 0.1 as required by the client.
So, with all this technology, we need to centralize the software. We designed an application that communicates over Bluetooth with the entire system made on the Android. It runs all your experiments seamlessly. You can use it as you go. It has instant data analytics. You can see the averages, the means, the raw data, or graph it on the go. And it's also Excel friendly as it exports to CSV as well. We also added an extra bonus, which is a web interface. Basically, it's a centralized repository where you can store all your experiments and you can see them later on in the comfort of your own home, not bound by the wind tunnel. It also allows you to search other experiments other peers have made public, so you can share and create new data as well. So now we're going to show you a quick demo of our system. So this is the application. As you can see, it's entering the experiment name, the wind speed, samples. We have 3 samples for speed, and the time interval between samples. That's the basic data. So that's the Aerobal controller via Bluetooth. Start your run. The application will seamlessly show you, like, this is the wind tunnel, ask you, the wind tunnel is empty for calibration, it's running, it will then send an emergency as needed. Right now we're going to show you a dual display of what is actually happening in the system right now. So this is when it first starts the motor, it actually displays it. This is the variable frequency driver, it goes from 0 to that speed and it's really fast. Also, the user can see the sensors directly. The Android is basically showing that the system will continue operating regardless of what you're doing. And the tablet, so it's completely seamless. You can keep browsing the internet if you want. You can see if the object is placed. Press OK. I'm supposed to press OK eventually. There we go. It's running. And now we're displaying simultaneously the car with the NMR running, stopping, going, taking all the different measurements it needs. It's not really a lot to see. So we're going to go directly to the part when it finishes. So the application shows you, here's the stats. As the wind speed, the direction, temperature, humidity. We're going to see the data. Here are the averages of pressure. The raw data, you can see. These are the points we took for each step. You can also graph your data as well. So graph, select the axis that you want to graph. And this time I think it's just time versus humidity, which is pretty constant. You can see you can adjust dynamically everything. And here's the summaries, and that's the end of the demo.
So I will be talking about the budget assigned to the project. The project was funded by the Civil Engineering Department with a limit of $5,000 assigned to the project. The components we use, the variable frequency driver costs around $3,100. The pressure sensor array costs us around $200 for all 16 components. The other components, which includes computer use in the facility, the Bluetooth model, and the logic circuits used to build the system, cost around $1,000 for a total of $4,200 of cost of the system. So in conclusion, we have provided an automated solution for the experiments conducted in the wind tunnel at the department. We have achieved electronic measurement of all of the sensors required for every experiment. These sensors are read in a centralized manner such that the user can view it in the mobile application, control the system from the mobile application, and view the results in the web interface provided by the system. So, any questions? Thank you very much.
¿Qué tipo de motor es que tienes tú?
The model.
Contéstame en español que ya yo sé que tú sabes hablar inglés. ¿Qué tipo de motor tienes tú, Nelly? ¿Un motor de C? ¿Un motor de
Es un motor AC, disculpa. Es un motor AC, tiene 460 voltios, y 36.7 de amperaje. El VFD se configuró para que no pasara, para que limitara el output a estos parámetros. Un motor AC trifásico. Está en la configuración wire. Esto pues, se hizo la configuración del motor se hizo por el doctor Andrés Díaz, que es el que nos proveyó la solución de llevar a cabo el control del motor con el variable frequency driver. ¿Alguna otra pregunta?
¿Alguna pregunta a la audiencia?
Dirían que la liberación que se conectaba vía Bluetooth
Sí.
se usaban para lograr la conexión.
Para el device, el microprocesador tiene un Bluetooth conectado con el cual se comunica por UPRM, que eso es comunicación serial estándar utilizado, y esencialmente nosotros creamos un protocolo, un API para el micro, el cual por medio de ese API pues, podemos accesar todos los sensores del sistema en cualquier momento que sean pedidos por la aplicación móvil. Nuestro cliente de esa parte está aquí presente. ¿Vale?
Estoy encantado de lo que han hecho. Primero que puedo decir, si va a venir la pregunta, pero quiero clarificarle algo primero. El túnel de viento tiene muchas utilidades. Ya no es la herramienta 1, es computational mechanics la herramienta 1, pero la validación es el túnel de viento. Así que siempre va a haber un parámetro físico que hay que decir sí o no, y para eso es que tenemos el túnel de viento. Lo que estos muchachos han hecho, yo sí reconozco lo siguiente. En el 93, cuando yo empecé a trabajar con esto, había una flat view y se hizo un esfuerzo, pero lo que ellos han logrado es mucho más allá. Físicamente el túnel opera por una ventana, la ventana me permitía solamente entre 27 y 50 millas por hora. El túnel lo que hacía era un templaqueo. Y esta variable frequency lo que permitió fue que ahora yo te puedo hacer esos dibujitos que viste al principio del carro con las líneas de cruz. Eso es misión imposible. Ahora es misión imposible, porque eso ocurre solamente a velocidad de 10 bajitas. Así es que ese logro es un plus dentro de lo que el túnel, las capacidades del túnel puede hacer. Sé que son 15 minutos y ustedes han hecho un montón de cosas y ellos han hecho la. Lamentablemente no da tiempo para que vean lo que es los 16 sensores a la vez pidiendo. Así que háblenle un momentito sobre los sensores esos para que ellos cuando menos puedan entender el propósito de esta parte que por limitación de tiempo no le da tiempo a ustedes a presentar.
O sea, para que se relajen, se merece un aplauso porque se han hecho.
Pues el Pressure Sensor Array es el device que nos permite leer 16 puntos de presión a la misma vez. Esencialmente se hace un doubling entre todos ellos, o intercambio entre todos ellos, con una frecuencia de 5 Hz para medir los 16 devices. 5 Hz, o sea, se está midiendo alrededor de 80 Hz. Esto nos permite entonces medir diferentes puntos de una estructura para analizar esa estructura. Cómo afecta el viento ya sea en los lados de la estructura, al frente de la estructura, arriba de la estructura. Eso se puede hacer un modelo que lo que hace es que se le ponen los sensores con unos tubitos y puede saber cómo afecta la presión ya sea a un edificio o a otro artefacto que se quiera medir, se le quiera medir cómo está afectado por el viento. En el caso del edificio se usa para ver cómo el viento impacta a ese edificio y para pues, construirlo adecuadamente.
Muy bien. Era para que ustedes vean que hay muchas más cosas que se hacen al túnel y que con lo que ellos están logrando hacer, pues más se puede hacer. Antes teníamos 48 puntos para medir. Ok, ya arrancando con 16, pero yo les pedí siempre, dejen esto abierto para el futuro. Así que dentro de lo de ellos también está de que este equipo, esta programación y estos módulos son expandidos. Y eso es algo algo que yo les pido a ustedes en su futuro, siempre busquen. Ustedes tienen un conocimiento en computadora que me encanta. Y escucha al otro, el experto en algo, a completo, y van a ver que el producto es mucho mejor. Y siempre piensa al futuro. Eso me dicen que es rentable. Así que felicidades.
Gracias, hermano.
Mi pregunta fue contestada porque era relacionado a los diferentes puntos de impresión.
Ok. Ok, gracias. ¿Alguna otra pregunta? Muchas gracias.